Right, folks. Once again, I'm here to finish off the discussion we had on probability as second topics in day six. So here we have a bag with a total of 10 balls with one probability that the ball is blue. So like we did last time, probability that the ball is actually blue, it will be given by whatever we do. It's out of 10. Then we check how many blue balls we have. There are actually 5. So we'll simplify our solution to 1 over 2. Then we're moving to conditional probability. We're given a condition here that one probability that B happens given A is occurred. So this probability is expanded as a probability of A intersection B all over probability of A. So we are given the intersection which will go on the numerator now, and I substitute the 0.15 all over probability of A, which is 0.3. I did my calculator here to divide 0.15 by 0.3, which will give me 1 over 2, that's 0.5. So this simplifies it to 0.5. Now I'm on the last problem here. Now this last problem is asking us to complete a given probability table, and the teacher has to provide the table. So the table that I have for you guys, it's a contingent table. Let's have a look. This is a contingent table where I am saying um, I've got a total of 40 there, and I've got 0.25. So if I look at the difference, it looks like this part is going to give me, let me change my color to 0.15. And here I'm going to get 0.2. Now, if I add 0.25 and 0.15, the result is 0.04, but the below problem 0.2, 0.35. It looks like our table there is going to be of an error. Let me try another table below because our numbers are not balancing. Because if I try 0.2, I think these are some of the things that you need to inspect. 0.2, 0.35, it gives us 0.55. And if I try this sum, it doesn't add up to a 1. Hence, it's forcing me to move to the next table so that we can see if we can discuss about it. So let me just erase this, then we'll properly discuss about it. These are values that have been calculated before, but let's try and check if we can make sense here. Pick my eraser. All right, I'm hoping this table might assist us. Let's see, that's a contingent table where we are saying if we sum column wise, we'll end up with the total value below. Same applies. This comes from the total above, total above. So in essence, if I put 0.5 there, it means this should also be 0.5, so that when I add it gives me a 1. Now I put 0.12, I put 0.5. It looks like what's short here should be 0.38, so that when I add the 2, they add up to 0.5. So let me try this term around. It looks like 8 plus 8, it gives us 16 carry 1. 3 plus 1, 4, plus the one we carried 5. So I'll be having 0.56. And it looks like on this table it's working, because when I add these two, they give me a result of 1. Then finally, I'm going for this value, but we are saying whatever the value is, if we add up to 0.12, it will give us a result of 0.44. So if I look at the difference here, it's going to give me the value above, which I believe will be 0.32. We have our table. Now we can use it to find probabilities. For instance, here we are interested in probability of event A given L is occurred. So this will be expanded as probability of or intersection L or over probability of L. So when I'm trying to check on our table, O and L, it looks like they intersect here. So it means on my numerator I'll be having 0.32. Then on my denominator is probability of L. Probability of L is the total that we have in the row L. So that will be 0.5. I'll need a calculator to simplify this probability. So it's 0.32 divided by 0.5, which will take us to 16 over 25 or 0.64. So this simplifies it to 0.64. Then the next problem we're interested in the probability of event L given O. So if I come here, that will be, let me try and do it somewhere here. That is probability of L intersection O over probability of O. So if I say L intersection O and O intersection L, it looks like it's one and the same. So that will be 0.32. Then probability that we have online, it looks like we are focusing on mainly this column because online it is a total of 0.44. So means that's going to be my denominator here, 0. To be prepared 0.44. And when I do my simplifications, it's going to be 0.32 divided by 0.44, giving me 8 over 11. So let me have that as 8 over 11. Now I'm being asked to determine whether events L and O are independent. So we saw it earlier that when events are independent, it means probability of O intersection L is going to be the same as probability of O multiplied by probability of L. So O and L, we have it above is 0.32. So this will be 0.32. But the other side, we have probability of O. Let's check where we find probability of O from our table. O, which is online, 0.44. So I'll come down and write 0.44 instead for probability of O. So that's 0.44 multiplied by probability of L. Probability of L looks like we got it somewhere. It was 0.5, which is the only one denominator. So I'll be multiplying this by 0.5. Let me try and bring a red pen. You see, when I divide this part by 0.5, it gives me 0.22, and I'm testing whether it's the same as 0.32. So it's not true, hence we can say these events are not independent. So I hope you guys enjoyed the first part of probability. I'll keep on chaining more videos as I build up problems to solve. Thank you.